Okay, so in this video, we have to solve this inequality. So first thing I'm going to do is I'm going to move everything to the left side. So when you do that, you get x3 minus 5x squared plus 4x plus 2 minus x squared plus x plus 10. And then this has to be greater than 0. Now, we have to solve. So basically, first thing we want to do is we want to figure out what is x. Okay, so the first thing we want to do is we want to actually factor this out. So for the meantime, I'm just going to treat this like a regular function. So let's ignore the inequality for now. So we're going to say f at x is equal to, and of course we have to simplify this first. So we have x cubed, that is negative 6x squared plus 5x plus 12. So this is what we have when we simplify this. Okay, so now we're gonna factor this using the factor theorem. And one actually, or I believe -1 works for this. Let me just double check in my head here. Yeah, sorry, -1 works. So if we plug a -1 for this, so if we plug a -1 in for x, we get 0. So therefore, x plus 1 is a factor. So now I'm going to use synthetic division to find the other factors. So now we have x squared minus 7x plus 12, and that's equal to, I'm just gonna factor this now. -4 and -3. Okay, so when we factor this whole thing, our answer is x plus 1 times this. So now that we have all their factors, we can solve for x. So these are our x-intercepts. So now I'm going to erase this because we don't need this anymore. Okay, so this is what our polynomial function looked like after we moved everything to one side and we simplified it. And for the time being, that's all we need. So when you plug in 0 for x, you get 12. So our y-intercept is at 0.012. So now we're going to graph. So we're going to graph. So we're going to plot our x-intercepts. So -1, 4, 3, and 12 up here. Okay, so the order is 1 for all of these factors. The leading coefficient is, the sign of the leading coefficient is positive and the degree is odd. So it starts in quadrant 3 and quadrant 1. And we're just going to make a rough sketch. That's what the function looks like. Now, if you remember, originally, this is what this right here this is what we had to solve. We had to solve this inequality. And this is what it looks like after we moved everything to one side and simplified everything. So notice how this, we have to solve for when this polynomial equation is greater than 0. So what we have to do here is, now that we graphed this polynomial equation, we see that this polynomial equation is greater than 0 in this area and over here. Sorry, this should go further down. This entire arrow here and this area right here. This is when it's greater than 0. So if we want to solve this using interval notation, we can say x is an element. Now this is greater than 0, not equal to 0. So we're going to use a square bracket here. So it's greater than 0 here, because -1 is greater than 0, and at 3, before 3 it's greater than 0, and it's not equal to 3, so we're going to put a square bracket here. And this represents and it's greater than 0 after 4, so we're going to put a square bracket here for 4, and this just goes on for infinity. And a square bracket for infinity, always a square bracket for infinity. So this is the answer to this. When is this polynomial equation greater than 0?